Hey guys, and welcome back to the Data Analyst Portfolio Project series. In this episode, we are diving into the first technical part of our marketing analysis project. Today, we're going to look at extracting and cleaning marketing data using SQL. We'll go through different SQL transformations that will be applied to each table in our data model before we bring the data into Power BI. We'll break down the SQL queries step by step, explaining each transformation and its purpose. If you haven't watched the previous episode where we introduced the project and discussed the business case, then make sure to check that out first. You can find that in the description. I have the links and all the information to be able to find that there. That being said, we are ready to take a look at the queries and the transformations that we're going to do in this project. Okay guys, so here we have some different SQL statements that we're going to walk through. We're going to break them down and I'm going to explain as we go. We're going to start on a little bit on the simpler side, and then we'll get a little bit more advanced as we progress through the different statements. What's important is that there is a database called portfolio project_marketing analytics. You can find the link for that in the description of this video. You need to restore that backup file onto this SQL Server Express server that you have so that you can get these tables available for you also locally. That is what I show in my video on how to set up and create a practice environment. So if you haven't done that, make sure to go back and check that video. That's also described in the description. So before you can do this, before you can follow along, you need to make sure that you have this database attached on your SQL server, and you can find all of the instructions to do that. The first statement that we will walk through is the one that is on our product data. Now you'll see in these statements that there is a top part, and I've added some almost like a divider. I will share these SQL queries on my GitHub. Again, link in the description. Everything is there. This part above these stars will not be there. That's just for me to go a little bit back and forth to show you guys the table before and after. But just follow along. If you have any questions, ask in the comments. And I think this is going to be quite useful. I've also tried to really add comments on the different parts for you guys to understand, what is going on here. But let's just start by looking at the product's data. What does the products table look like before anything has been done to it? So we're going to mark this up and execute this part. So here you can see we have a product ID, we have a product name, we have a category, and we have a price. Now right away, this table is fine as is. One thing you're going to see is that I am going to comment out the category column, because I think it's a bit redundant when we have just products and all the categories is just one. So I'm going to remove that in our final query. Then there's one thing that I'm going to do, and that is I'm going to case this price, this column, and I want to make a category. For when the price is above or below something or within certain amounts, I want it to go low, medium, or high. And I'm going to store that, or we're going to turn that into a price category column. Now, the values that you decide here, I'm going to let you guys decide that, however you want. But I recommend that you just, you write this statement out and try to understand what is going on here. Because what we're doing, we're doing a comparison, we're doing a case, and when something is fulfilled, then categorize it as this text. When it is between these bands, this text, else this text, and end it and return it as this column, which becomes price category. So it's fairly, this is a simple start. We're going to start a little bit soft with a query here. There isn't anything else that we're going to do on this table. But if I show you guys, if I run this, now, and if you're new in SQL Server Management Studio, the part that I mark is what is going to be returned in this window, this result window down here. So I mark up this query now, execute, and now you can see that we have this new column. We have this price category column, and you can see that there's a high, medium, low, and the point of doing that is just if a company wants to have an easy way to understand how many products are selling within a certain category, it's easier to have some buckets than having these values and having to just try and understand for yourself what is high, medium, low. So I've just decided to add that category there. Also, you could also just go Control A, select, then you will see both. You'll see the first statement, which is this one, and the bottom statement, which is the result of this one. Now, like I said, on my GitHub, I'm going to add these SQL statements there. It'll be the exact same statements, but it will be without anything that is above this star and the stars. We don't need that. This is the statement that that will produce this result, and this is the statement, or the result of this SQL query is what is going to be used in our dashboard later. But I recommend that you guys go in, look at the video, try to write the statement yourself, look at the different comments that I have added, and try to understand what is going on here. You can see here is the part where I commented out the category because I thought that was a little bit redundant. Now it's back, but let's take it out again. If you get other ideas of things you want to do, then please go ahead. There's no right or wrong answer here. What's important is that the steps we are applying in these SQL statements is going to make our opportunity and use case more analytical driven and better later for the dashboards. So we're going to add and do some improvements here so that the output becomes better, cleaner, more structured in the Power BI dashboard at a later stage. But this is the first one. This is the one that relates to product information. Great. The next one then is going to be about customers. Now, this one is a little bit more, a little bit different. What we're doing here is we have one customers table and we have one geography table. And I'm going to mark both of them. We'll get two different results. So you can see we have a customer ID, we have a name, we have an arbitrary email, gender, age, geography, right? This geography ID is going to correspond to an ID in the geography table. And what we're doing here, we are trying to create a combined table. So like I said, this, the stars and above, that's just for me to show you guys. Below is the actual query that we're going to focus on. So we can then just go back to, let's say if we have customers, that's what that look like by itself, or we have geography, this is what that looks like by itself. Now if we go down, you can see this is a join, a statement which is going to combine these two tables. So we have a select, and we are selecting from the customers table as C, where we're gonna alias all the columns that comes from this table in this statement, and then we're selecting from the geography table as G. So you can see customers over here, that's this table, geography over here, that's that table, and we have a left join on this condition, where geography ID from the table which has been aliased with a C onto the geography ID on the table which has been aliased as G, which is geography, customers. We are going to then read it, select customer ID, customer name, email, gender, age, with this alias to kind of tell the select statement which table does this come from. And then we're going to add the country and city from this other table on this condition. So this is a left join. If you want to, you can go in and you can change it to a right join. Actually, let's first look at the result of the left join before I start changing the join criteria. So we can mark this part off, execute, and now you can see we have a table which combines customer information and geography information. So in this dimension, we are doing a join, and it's because we don't need two different tables. We can combine them into one. Fewer tables in our data model, more efficient. It makes sense. it's fine. This is the combined result that we want to get into Power BI at a later stage when we're going to do some analysis. And this is a left join. So these two columns have been added to the left table, which is the first one in the join, which is customers. Just for the sake of it, if I comment this out and I do this as a right join, let me see if I can get this part here. You can see now it's going to list the cities first because those are the values that comes up in the geography table first, and then it adds whatever matches on that from the customers table. So this becomes the first table on the right side and is joined into that. And then there's an inner and full outer join, just some other types. In this example, it doesn't really make any difference, but I've just added those there in case you want to comment in and out and just look at it. But the purpose of this one is for you guys to just do a quick practice on selecting two different tables, combining them. And again, from a more sensible point of view, why are we doing this? It's because we don't need two different tables. We can combine them, more efficient, fewer tables in our data model. It's you know, it just makes sense. Here you can see we have an age. We have a, let me get this like this. We have the country, city. If you want to, you can go in, you can case the age column into let's call it, you know, different categories of age, like young, middle age, old, or some other ways of putting it. Or you can do countries, Northern Europe, Western Europe, Eastern Europe, Southern Europe, if you want to. I'm just trying to come up with some ideas for you guys. You could have city. You could categorize them into large or small based on number of people that lives there. There's different things you can do here to categorize it or put it into a context, which means that you can use it more in a different analytical point of view. And that is what we're trying to do with the SQL here. So far we have two dimension tables. They are going to become what we call dimension tables in a data model, or lookup tables. So if we have let me see if I can draw this out for you guys. Say we have a data model, and we'll come back to this later in Power BI. But let's say we have, let me find, I haven't done this forever, that's for sure. Let's go. Okay, so if we have customers, geography, and then we're gonna have some tables down here. Excuse my paint drawing skills. So these are going to be dimension tables, and they're going to filter down onto these tables. They're going to filter the fact tables, which we will just get to. This will be a little bit more clear when we get into Power BI. I'm just trying to get it out there already. We have some tables down here, which are fact tables, and some tables here, which are lookup tables or dimension tables. So far, we have done category changes, and often you do that on dimension tables, or we've combined different dimension tables. Often something you do on dimension tables. Now we're going to go into the tables that will hold the calculations and what we call facts. So the first one we can look at is also a simple example. It is the one that has some information about customer reviews. So let's take a look at that one. You can see we have a ID of the review. We have the customer which did the review, the product ID to identify what product was reviewed on, what date, what was the rating, and what is the text. Now, the issue with this one is that in some of these reviews, there is a double spacing instead of a singular spacing. So I've just added a simple replace on double spacing with single space. That's the only thing we're going to do on this one for now. So we can do this, we can select it. You can see that it looks a little bit cleaner. So we've done a small fix there. This is also the table that we're going to work on in Python later. We have a rating and we have a text. And what we're going to do in Python is something called sentiment analysis. I'll just very quickly explain what it is. We will try to determine if the text in this text is positive or negative, and we're going to combine that with our understanding of the review text and the rating that they gave to see if we can make it even more accurate or some other types of information. So that's in the next episode, but I thought I'd just explain to you guys what we're going to do. But that's what this looks like. This is a fact table, which means we can have an average of rating. When we get the sentiment in, we can have a rating sentiment score or a rating sentiment category. Like I said, we'll come back to that later. But here, the rating and what they have written is something that we want to understand based on the product or the customer that did it. So the customer and the product, that gives us context. Who was the customer? Which city is he from? How old is he? What gender is he? The product tells us about the category of the product or the product type or the low, medium, high products. That will then be used to filter the rating to understand how this comes together. So this would be one of these tables down here. Let's say it's this one. Okay, so the next fact that we're going to look at is the engagement data one. And you can see, this is what it looks like before we have done anything to it. And we're going to do some different things here. Just to point out, some of the issues and what we want to try and fix or improve, if we can call it that. One thing is that in this content type, you can see there are some different spellings. Blog, video, newsletter, social media capitalized. I want to make this a little bit more uniform. We're going to do that. I want to change the format on engagement date. I think I'm going to restructure these IDs to come a little bit sooner. And then the views and clicks combined column, I want to split that. So that's what I've done here, and I'll take you guys through that also so that you guys can see what this will be like. So the first is just selecting the different IDs first. I think that's always useful. You can see I've used an upper function and I've replaced this way of writing social media with this one. And I've used the upper to standardize the spelling, or let's call it the case in the values in the content type column. Left of this combined column becomes views. Right of the same column is going to become clicks. We have the likes column, stays as is, and I've done a small format and conversion on this column to a date column, and then change the formatting. I've also filtered out one of the content types because I don't want to bring in the newsletter rows. So I have all the comments. Read through it. I recommend that you guys type it out and just practice that part. I just really want to break it down and make sure that you guys understand what is going on here. So I'll mark that. We'll execute it, and this is what it's going to look like afterwards. So you can see now, these columns are coming first. Standardized content type spelling, views, clicks, likes, engagement date. This is what is going to go into Power BI. And we've introduced a couple more SQL concepts now, a little bit more advanced, but still I think it's manageable. If you want to see the query, like I mentioned, check the description. You'll find all the links to find these there. The last one is this customer journey table, and this one is a little bit more advanced. So I want to try and take you guys through this one, and then we'll discuss as we go. If we start by just looking at this customer journey table by itself, it is showing different IDs, the journey ID, customer product ID, the date they visited, different stages, and an action that they did. This is just to look at different customers and journeys that they have done in a funnel and see, did they view a product, did they click, did they buy something, where did what happen? And we have this duration column, which is missing some values in some places. So we're going to try and fix that. The other thing is that there are some duplicates in this table. There are some rows which has the exact same information. So we're going to try and I'm going to show you guys that first, and then I'm going to talk you guys through how, one way of doing something about this. So this first part of the statement is going to show you guys which rows has exactly identical information, which is duplicates, and that could be a data quality issue. Now you can see it says here, we're selecting a bunch of columns, and I'm going to go into this, but let's focus on this one especially. We've given a row number, which means that if a row has a unique combination, it has been given a number. And if that number is greater than 2, it means one row has a unique combination of customer ID, product ID, visit date, stage, and action on more than one row. I'm going to show you guys in a second. But let's just start by commenting this out. And this is a common table expression which gives us a temporary, this becomes a temporary table which we can then run a query on. We can use this information which is only there during the query, during the execution, and then it goes away. So we get a result for this, and then we pull that with this selection. So you can see with duplicate records as some conditions, we're going to select from that and do an order, but that's one step at a time. So we will mark this one off and then execute it, and then you can see here. So you can see there's a bunch of different row numbers going downwards, and they're all 1. But this is our first example. You can see the information on this row is exactly the same. That's why this is the first occurrence of this unique combination, and this is the second occurrence of this unique combination. And that part is done here. It is doing a row number over the partition, over let's call it the combination of these unique fields and order by this ID, and give it a row number. So if it's only one combination that is unique in this partition, it's going to get 1. But if it's 2, then it's going to get 2. So this first part is only for us to verify, sorry, let me get the whole thing, only for us to verify that there are some duplicate records. I'm letting you know that there is, because that's part of this exercise, but this helps us create a statement which can identify how many unique how many rows do you have per unique combinations. And if you have 1 row, it gets only a 1 number, but if it gets 2, it means there's 2 rows that has the same unique combination. So if I then take this back in, where row numbers is greater than 1, it's only going to return rows where this happens, where there is a unique combination which has gotten a row number which is greater than 1, which means the unique combination has been repeated more than once. So we have this statement with a temporary table. We run this statement on top of that temporary table, and it verifies that there are 79 rows where there are duplicate records. So that's just the first part. This is just a verification. That's called a verification query. This bottom part is what is going to fix this and one more issue. The other issue is that there are these nulls where they're missing a duration. So we're going to have a subquery. This is a subquery. This is a subquery, and that is a query where we're going to get the average duration over the partition by visit date. So for each visit date, we are going to figure out what is the average duration, and if we're going to use this part to look at duration, if there is a null, then put in that average duration amount into the duration column, or else just keep the duration amount that was there. So if this one is null, I want to know what was the average duration for that date and use that value there because I don't have anything else there. So that's the best I can do. And that is based on this subquery right here. So it's a coalesce as duration from this. And then we have the row number 1 that is also happening here to identify duplicates. So this query is going to remove duplicates, and it's also going to add an average amount into our nulls. So if I go select on this one and I execute that, you can see that then we shouldn't have any duplicates. And if you see duration, you can see there are some decimals here now. These are decimals that have been entered as averages on those days where there was a missing duration. So row numbers equals 1, and let's see if I can do this, equals, I think it was 23. So if you remember, journey ID number 23 previously had 2 rows, now it only has 1 row. So we have confirmed that there are no duplicates here. So we only keep this part. Let's go back like that. And if you want me to verify that for you, we can go back and select this query. You can see journey ID number 23 had 2 rows before, because there's the row number 2 exists because there are 2 rows that got assigned a 1 and a 2 as the combination is unique across 2 rows. So this is the one that is going to go into Power BI for this table. Now this one was a little bit heavier. Here we are trying to handle some more complex stuff. I've tried to add comments to what is going on. I really recommend that you guys go in, open this SQL query and try to look through it. Again, remember that this part is for me to show you guys the table before. This part is just for me to show you guys a query to verify the duplicates. It's good to have. But later, what we're going to pull into Power BI is this part, because this is going to be the part that is going to actually return the data as we want it. I've decided to do the partitioning by visit date as average duration. If you want to do it per something else, different columns, try to enter, product ID or customer ID. You'll see that the duration is going to be a little bit different. But it's important that you understand what it is doing. It is the same with this row number. Try to understand when it says partition by this, and this, it's doing it across a unique combination of those. And if you have 2 rows which has the exact same information on both rows, it becomes a unique combination twice. And that's why you have a row number which becomes 1 and then becomes 2 on the second one, because you have 2 rows with the exact same information on them. So these are the different tables that is going to become our data model in Power BI. Take a look at them, different concept that goes into each one. If you have any questions or it got very complicated, let me know in the comments. If this part got difficult, then take your time to try to understand what are the different parts. I hope it is understandable. I understand that there is a certain level of complexity here, but I'm trying to make this something that exposes you guys to different concepts and different things that I think is useful to understand in terms of SQL and what we have to do with the data sometimes to get data into the analysis tool, which we can use to find information and insights and stuff we can bring back to the business, so that they get some value of this data with and without the shortcomings that we're trying to work on with our SQL in this project. That's it for our episode on extracting and cleaning marketing data with SQL. Now you know how to connect to a database in SQL Server Management Studio. You know how to extract relevant data and apply some cleaning techniques to prepare your data for analysis in Power BI. In the next video, we are going to enhance our data by performing sentiment analysis on customer reviews using Python, which will add valuable insights to our marketing analytics project. Make sure to like, subscribe, and hit the notification bell so you don't miss any of the updates on this series. If you have any questions or thoughts, then leave a comment below. I'd love to hear from you guys in the comment section. Thank you guys for watching, and I will see you guys in the next episode.